Okay, we're on the left-hand side of our notes. We're going to start with number 2. Number 2. So let's see. Identify the one angle that is not coterminal. Identify angle that is not coterminal. Okay, so basically it's saying that all of the angles that I give you here are going to be coterminal, except for one. It's like that Sesame Street game. So 5 pi over 3, negative 5 pi over 3, 11 pi over 3, negative 7 pi over 3, and 365 pi over 3. Okay, go ahead and take a second to figure out which one of those angles is not coterminal with the others. Okay, remember when we're doing stuff in radians, we can use a calculator. Just leave off the pi and just assume that there's always a pi on there. It's kind of like combining like terms with an x. 2x plus 4x is 6x. 2 pi plus 4 pi is 6 pi. So let's start with the first angle, 5/3. And you can add or subtract 2, because that's 2 pi. Add or subtract 2 pi. So maybe plus 2 and make it a fraction. So 11/3 pi. Okay, so those two are coterminal. So I have to find the one that's not like those. Whoops, you can't even see what I'm doing. There we go. 11/3, 17/3. When I get to 365 eventually, is this going to take too long? What do you think? I guess I could find, divide 365 thirds by 2 and then take, oh, there it is. Okay, so that's okay. Let's start at that first line. Whoops. Let's start back at that first line, that 5/3, and subtract 2 instead of adding 2. So 5/3, and then minus 2. That gives us the negative 7/3, and we missed the negative 5/3. So negative 5/3 pi is the one that is not coterminal. It's not, you can't get for all of these other angles, you can get from one to the other by adding or subtracting 2 pi or multiples of 2 pi, except for negative 5/3. You'll never get there. Let's try number 6. Number 6, evaluate 6 trigonometric functions of the angle theta. Okay, so here's our angle. The point is 3, negative 5. Evaluate the 6 trig functions. Go ahead. Whoops, let me write my instructions. Evaluate 6 trig functions. All right, go ahead, pause. Alrighty, the 6 trig functions, sine, cosine, tangent, let's see, cosecant, secant, and cotangent. Sine, let me draw my triangle here. That's 3, 5. So what's this side right here? It's going to be negative 5. 3 squared plus 5 squared, take the square root of that. It's the square root of 34. Okay, so the value of, I suppose we could say the value of r there is square root 34. Okay, and just to go back to our notes real quick, we had this bit here, the adjacent side is x, the opposite side is y, and the hypotenuse is r, and we can use those as well to kind of think about this here. So let's see, sine is opposite over hypotenuse, sine is, that would be the y coordinate over r, so negative 5 over square root 34, this would be 3 over square root 34, tangent opposite over adjacent, negative 5 over 3, and then for the other side, just do the reciprocals. Negative square root 34 over 5, square root 34 over 3, negative 3 over 5. Okay, and again, with our all students take calc device, all students take calc. This is 4th quadrant, so cosine should be positive, which it is. Groovy. And thus secant is going to be positive as well. Okay, we're going to try two more. Let's look at number 16. Number 16. State the sign of sine, cosine, and tangent. Ooh, we're going to use that all students take calc thing. So 16, 3 pi over 2 and 2 pi. So we're going to have A is sine, B is cosine, C is tangent, positive or negative, and we're between, number 16, we're between 3 pi over 2 and 2 pi. So on this interval, are sine, cosine, and tangent, are they positive or negative? Go ahead and pause. Okay, all students take calc. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Where you can add 2 pi and it's still the same angle, so that's okay there. Between 3 pi over 2 and 2 pi, that's right here in this area. So sine, is it positive or negative? Well, sine's the only function that's positive here is cosine. It's positive, the other two are negative. There we go. So that's number 16. Let's do one more, number 22. Last one. Number 22, choose a point on the terminal side of theta. So theta equals 2 pi over 3. Okay, and you have three choices. One of them is going to be on the terminal side. So negative 1, 1. Negative 1 and 3. I'm sorry, negative 1 is square root 3. And negative square root 3 and 1. Let me, beautiful. So choose a point that's going to be on, I'll just say on theta. All right, go ahead, give it a shot. All right, first off, 2 pi over 3. Where in the world is this? It's in the second quadrant, okay, because it's more than 1/2, but less than 1. Remember, this is pi over 2, and this is pi, more than 1/2, less than 1. So it's going to be in the second quadrant somewhere. So first things first, there's my angle. Now, double check these. These are all also in the second quadrant. So if one of these points was in the second quadrant, that would give us a way here. Let me see. 2/3 pi. Let me look at my unit circle. I'm going to look at that real quick. The unit circle point is negative 1/2. And square root 3 over 2. That's the point on my unit circle there. Now, trig functions are ratios. So every point along this line would have the same ratio as these 2 points. Every single one will be like a multiple. Like if I multiply both the points by 7, negative 7 over 2 and 7 square root 3 over 2. That will be on the line somewhere. It's a direct variation. It's a line that goes through 0. So all I need to do is figure out which one of these points is a multiple of this point right here. And I would say this point. Okay, if I multiply this point by 2 or go twice as far away from the origin, that point right there would be on the line. So the point is negative 1 square root 3. And I think that's the easiest way to do it. You can think about trig functions, but you still have to work from a point that you know, I think, to get another one. So I think that's probably the best way to do it. Some multiple of that unit circle point. Okay, 3 questions. And your assignment. Yippee-ki-yay.